All right, here's a really hard problem for chapter 1, and that's free fall. So what happens when we throw something up in the air? You're going to be able to tell me the height for any time. We're going to make it a little bit easier by making it work so we can factor it. So the free fall equation is going to be factorable, which means we'll be able to solve it without the quadratic formula. Later on, we'll do the same thing, except use the quadratic formula. So today we're going to factor it, learn how to do this with factoring, and our answers will come out to be even fractions. When we do the quadratic formula, they'll be decimals. But when we do this, it'll be a fraction. So this is going to work out evenly, I hope. Let's see. Okay? So I'm going to tell you we're going to throw it up at 72 feet. No, it's a 72-foot high grandstand, and we're going to throw it at 56 feet per second. So those are the two things you need to know in order to do the free fall problem. So it's starting at 72 feet. So we know right here, here's 50. If we start here 0 along the y-axis, we're going to count the height, but we're going to count by 10. So 10, 20, 30, 40, 50 feet, 60, 70, 80, 90, 100, up to 150 feet. So we're starting at time 0 at 72 feet. So that's going to be right here. So there's 72 feet, and that's where we start. Okay? So that's going to be the y-intercept. And of course, in our equation, that'll be the number that's by itself, 72 feet. Let's see, am I counting that right? That looks pretty good. So here's our height equation. You're going to need to know this. You can put it on your cheat sheet. The height is a function of time. Is going to always be negative 16 on Earth, planet Earth, times time squared, plus the velocity. So it's going to be plus 56 feet per second times time, and then plus the initial height, which is 72. So our equation starts out looking like this. Okay? When it hits the ground, so what we're figuring out is when it's gonna be equal to 0. When it hits the ground, the height is going to equal 0. So we're going to take this whole thing and just make it equal to 0. Well, if we can factor this equation, then we'll be able to solve it and figure out when it's going to equal 0, when the height will equal 0. So the way we factor hard equations like this, just like we learned, in class, is we put them in descending order. We factor out negatives, so to make the leading coefficient positive, and factor out all common terms. So let's see here, 56, is 56 divisible by 4, 56 divided by 4? Yeah, we can take a 4 out of each one of these. I don't think we can take an 8 out. No, we can. 56 is divisible by 8, isn't it? So we can take an 8 out of each one of these terms and a negative. So I'm going to factor out a negative 8. That's going to leave me 2t squared. If I take a negative 8 out of positive 56, it's going to leave me negative 7t. If I take a negative 8 out of 72, that's going to leave me negative 9. I'm thinking about that correctly. Is that right? Does that make sense? So I took a negative 8 out of each of these terms, write it out in front. Don't put it underneath. Write it out in front. So we factored out a negative 8 out of each term. Okay, now what we have to do is we have to factor this trinomial that's left here. So you could do that by guess and check, or you could do it with the x method. I'm going to use the x method. I'm going to multiply 2 times negative 9 and get negative 18. And then I'm going to write negative 7 at the bottom. So now I'm going to say what two numbers multiply to negative 18 and add to negative 7. And that's not too hard. And it's going to be negative 9 and positive 2. So to factor this, I write down, make two parentheses. And I write down 2t twice, even though I know that's not the right answer. I write it down at the beginning of the parentheses twice. And then I put the numbers on the side of the x here in here. So it's going to be minus 9 and plus 2. And now I divide both parentheses by the biggest number. It evenly divides both terms in the parentheses. So here it's just going to be a 1. Here it's going to be a 2. And that makes sense because I wrote 2t down twice and I divide by 2 once. So I end up with 2t minus 9 and t plus 1. I still have that negative 8 in front. and that whole thing is going to equal 0. So this equation here I've transformed into this equation. Those two things are the exact same thing. Does that make sense? Negative 16t squared plus 56t plus 72, I can rewrite in this simpler way as negative 8 times parentheses 2t minus 9 times parentheses t plus 1. And if I make that whole height equation equal 0, that's when the ball is going to hit the ground. So I put the height equal to 0 over here, and then I look at this and say, well, that's not too hard. If these three things here multiply together, there's three things that are multiplying together equal 0. If three things multiply together equal 0, one of them has to be equal to 0. That means either this parentheses has to be 0, this parentheses has to be 0, or this parentheses has to be 0. Well, this parentheses can't possibly equal 0, so forget about that. But this one can. 2t minus 9 could equal 0. Or t plus 1 could equal 0. 2t minus 9 equals 0. Bring the minus 9 over, it becomes 2t equals a positive 9. Divide both sides by t, and t equals 9/2, which is 4.5. So time equals 4.5 seconds. So that's one time when the ball is going to hit the ground at 4.5 seconds. Over here, this other parentheses, t plus 1 equals 0, means t must equal negative 1. And that's the other time when the ball will hit the ground at negative 1 second. And obviously, negative seconds is not going to happen, but the parabola does cross the x-axis at negative 1 second, although that doesn't really happen in reality. But the parabola does cross that, and I do want you to show me that on your graph. So we have two times when the ball crosses the x-axis, once at 4.5 seconds, once at negative 1 second. So up here in our graph, at 4.5 seconds, you're going to put a dot on the x-axis. So that's the time along the x-axis and the height along the y. So at time 4.5 seconds, the height is going to be 0. That's when the ball hits the ground. The other time when it's 0 is time negative 1 second. So I'm going to go over here to negative 1 second, and we'll put a dot on the x-axis there. Okay? So those are the x-intercepts at negative 1, 0, and 4.5, 0. So up here, what I want, when you fill this out and you fill out the blanks here, factor out a negative common factor, I want you to write this down. Negative 8 times 2t squared minus 7t minus 9. So when I take my original height equation, I factor negative 8 out, I get this equation. Negative 8 times parentheses 2t squared minus 7t minus 9. Now I want the factors, so then you're going to put in what you found here, which is negative 8 in front, and then 2t minus 9, and t plus 1. Right? So this factor down here, that's the factored equation. And then, of course, this gives you time equals 4.5 seconds, and over here I get time equals negative 1 second. Okay, so we know that the ball hits the ground or is at the ground at those two times, at negative 1 second and 4.5 seconds. The axis of symmetry, a parabola is perfectly symmetric. So if it's on the ground at these 2 points, the parabola is symmetric. That must mean that it's the axis of symmetry, the middle of the parabola, has to be halfway between those 2 points. So we take these 2 times. I take 4.5 plus a negative 1, and I divide that by 2. So I find the average of those 2 times. You add them up, divide by 2. That'll give the average of those 2 points, and that's where the axis of symmetry is going to be. So 4.5 take away 1 is 3.5 divided by 2. 3.5 divided by 2 on my calculator is 1.75. So the axis of symmetry is going to be at 1.75 seconds. That's when the ball is going to be at the peak. So on your graph, you're going to make a dashed vertical line at 1.75 seconds. So that's the middle of the parabola right there, okay? Now, we're going to find the height at the peak. So at 1.75 seconds, the way you find the height at any time is I just put the time into the height equation. So I want the height when t equals 1.75. So I just put -16 and I put 1.75 in for t, so 1.75 squared plus 56 times 1.75 plus 72. I do that on my calculator. -16 times 1.75 squared plus 56 times 1.75 plus 72. And that turns out to be 121 feet. So the height at the peak is going to be 121 feet. So if you want, you can go over here on the axis symmetry, go up to 121 and put a dot there. Here's 100, 10, 20. So right here, that's when the ball is at the peak. 1.75 seconds after we throw it up in the air, it's going to be 121 feet. That'll be the peak. Now I'm also going to ask you for the height at 1 second. So this is just, I'm just making up some times just to have you practice. So I want the height when t equals 1 second. It's going to be -16 times 1 squared plus 56 times 1 plus 72. So, I can do that on my calculator pretty easily. I can just actually go in and change the 1.75 to 1.00. So I don't have to type the whole thing in over again. And that's going to be 112 feet. So at 1 second, it's going to be 112 feet. So that's going to be right here. Here's 1 second on my graph. I go up to 112 feet. There's 100, 110, 112 if you like right there. And now here's a tricky thing. I want to find the symmetric point. So anytime you get a point on a parabola, because the parabola is symmetric, if I go the same distance on the other side of the axis of symmetry, I know the ball is going to be at the same height. The parabola is perfectly symmetric. Okay? So if I know it's 121 feet at 1 second, and it's 112 feet at 1 second, and 121 feet at 1.75 seconds, the difference between 1.75 and 1 second is 0.75 seconds. So I take the axis of symmetry time minus the time that I want to know about, and that turns out to be 0.75 seconds difference between those two. Between here and here is 0.75 seconds. And I add that to the axis of symmetry. I get the point on the other side where the ball is coming back down, and it's 112 feet. So these two heights will always be the same. So now I take 1.75 plus 0.75, and that turns out to be 2.5 seconds. So on the way back down, the ball will be at 112 feet at 2.5 seconds. So I go over here and I make a dot on my graph at 2.5 seconds and 112 feet. So those 2 points are symmetric around the axis of symmetry. And you can draw a little, line to both of them, and they should both be the same distance away from the axis of symmetry. And that distance is 0.75 seconds. Okay? And now I can see the y-intercept. So this is going to be when x is 0, the time is 0. How high is the ball? Well, if I make this 0 and I make that 0, the only number left is 72. So at time 0, the height's going to be 72 feet. So that is right here. That's this point right here. And that has a symmetric point also. So if I go to from there, the axis of symmetry is 1.75 seconds. And if I go another 1.75 seconds, where do I get to? Well, that's just going to be 1.75 doubled. So 1.75 times 2 is going to be 3.5 seconds. So 1.75 and another 1.75 is this point right here, which is at 2.5 seconds and 72 feet. So the coordinates of that point right there will be 2.5 seconds and 72 feet. The x-coordinate is time, the y-coordinate is height. So now I can connect those dots. The ball comes down like this, nice smooth parabola. And then I know, let's see, is there anything else I need to find? No. So the symmetric point here is going to be 2.5 seconds and 72 feet. And now I can draw in the whole parabola. And it should look like a real nice smooth parabola. Both sides are equal. It's perfectly symmetric. And we filled in all the blanks over here. So take a look at that, go through it really slowly, and ask me questions if some of it doesn't make sense. Pretty complicated problem, very complicated. Height is a function of time. So this is all about functions. Very good.